Nitrogen is one of the most familiar elements on the periodic table. Its symbol is N, and its atomic number is 7. It sits near the top of group 15, among the elements known as the pnictogens. At first glance, nitrogen seems simple and ordinary. Yet, it continues to surprise scientists even today. For most of us, nitrogen is known as a gas. It makes up about 78% of Earth's atmosphere. Every breath we take contains more nitrogen than oxygen. Despite this abundance, nitrogen often feels invisible. That invisibility is part of what makes it interesting. The story of nitrogen begins in the 18th century. In 1772, the Scottish physician Daniel Rutherford identified it. He noticed a part of air that would not support life or combustion. This gas was clearly different from oxygen and carbon dioxide. Rutherford had discovered nitrogen, though it was not yet named. Other scientists soon studied the same substance. Antoine Lavoisier recognized it as a distinct element. He gave it the name azote, meaning without life. Later, the name nitrogen became standard, referring to niter-forming compounds. From the beginning, nitrogen was linked to both life and its absence. In its most common form, nitrogen exists as two atoms bonded together. This form is called diatomic nitrogen, or N. The bond between the two atoms is extremely strong. Because of this, nitrogen gas is very unreactive. It tends to stay unchanged under ordinary conditions. This stability has important consequences. Nitrogen gas does not burn. It does not easily form new compounds on its own. This is why it can safely fill the atmosphere. It acts as a calm background to more reactive gases. When nitrogen does react, it becomes far more interesting. It forms compounds such as ammonia, nitrates, and nitric acid. These compounds are essential for life. Plants rely on nitrogen compounds to grow. Proteins and DNA both depend on nitrogen atoms. Nitrogen has several known forms, known as allotropes. An allotrope is a different structural arrangement of the same element. For a long time, nitrogen was thought to have very few allotropes. Most textbooks focused only on molecular nitrogen, N. Recent research has begun to change that view. Scientists have discovered new ways nitrogen atoms can bond. Under extreme conditions, nitrogen behaves very differently. High pressures and temperatures can force atoms into new arrangements. These arrangements create what is sometimes called a new type of nitrogen. This is not a new element, but a new structure. One of the most studied examples is polymeric nitrogen. In this form, nitrogen atoms link together in long chains or networks. Instead of pairs, many atoms are bonded in sequence. This structure is very unusual for nitrogen. It resembles how carbon forms polymers, but with nitrogen atoms. Polymeric nitrogen was predicted before it was observed. Theoretical chemists suggested it could exist under extreme pressure. Later, experiments confirmed that such structures can form. They are not stable under normal conditions. But their existence changes how we think about nitrogen. The chemical properties of this new nitrogen are striking. The bonds store a large amount of energy. When the structure breaks apart, energy is released. This makes polymeric nitrogen scientifically fascinating. It also makes researchers cautious in how they study it. Physically, this form of nitrogen does not look like a gas. It behaves more like a solid. Its atoms are locked into a rigid structure. This is a dramatic contrast to nitrogen gas. It shows how structure defines behavior. The idea of nitrogen forming chains was once surprising. Nitrogen is known for forming triple bonds. These triple bonds are among the strongest in chemistry. Breaking them usually requires extreme conditions. Yet, under pressure, new bonding patterns emerge. This discovery highlights an important chemical principle. Elements are not limited to one form. Their behavior depends on environment and conditions. Pressure, temperature, and energy all play a role. Nitrogen is a clear example of this flexibility. Beyond polymeric nitrogen, other unusual nitrogen forms exist. Some are short-lived and only seen in laboratories. Others exist only in theoretical models. Together, they expand the chemistry of nitrogen. They remind us that even common elements have hidden complexity. Nitrogen's physical properties in its common form are well known. It is colorless, odorless, and tasteless. It becomes a liquid at very low temperatures. Liquid nitrogen is used widely in science and industry. Even here, nitrogen shows its versatility. Chemically, nitrogen can act in many roles. It can gain electrons or lose them. It forms compounds with metals and nonmetals alike. Its oxidation states range widely. This flexibility is central to its importance in chemistry. Nitrogen's role in biology cannot be overstated. It is a key part of amino acids. It forms the bases of DNA and RNA. Without nitrogen, life as we know it would not exist. This makes its chemistry deeply connected to life. Interestingly, most living things cannot use nitrogen gas directly. They rely on nitrogen-fixing processes. These processes convert nitrogen gas into usable forms. Bacteria play a major role in this transformation. Human agriculture depends on it. Modern industry has also learned to work with nitrogen. The Haber process produces ammonia from nitrogen gas. This ammonia is used to make fertilizers. These fertilizers support food production worldwide. Nitrogen chemistry feeds billions of people. The study of new nitrogen forms may influence future technology. High-energy nitrogen structures could inspire new materials. They could help scientists understand energy storage. Much research remains theoretical or experimental, but the potential is significant. It is important to note that these studies are highly controlled. They take place under specialized laboratory conditions. They are not part of everyday chemistry. This keeps the focus on understanding, not application. Knowledge comes before use. Nitrogen also plays a role in planetary science. Many planets and moons have nitrogen-rich atmospheres. Titan, a moon of Saturn, is a famous example. Studying nitrogen helps us understand these worlds. It connects chemistry with astronomy. In Earth's history, nitrogen has shaped the environment. Its stable atmosphere allowed life to evolve safely. It diluted reactive gases like oxygen. This balance was crucial. Nitrogen quietly protected life. The idea of a new type of nitrogen challenges assumptions. It shows that even familiar elements hold surprises. Chemistry is not a finished subject. It continues to evolve with new tools and ideas. Nitrogen remains part of that story. From a teaching perspective, nitrogen is a perfect example. It is simple enough to introduce early, yet complex enough to study for a lifetime. Its new forms add depth to its profile. They encourage curiosity and careful thinking. In summary, nitrogen is far more than an inert gas. It is an essential element of life, industry, and science. Its newly discovered forms expand our understanding of bonding. They show how conditions can reshape matter itself. Nitrogen remains a reminder that even the most common elements can still surprise us.